Hello friends, so today we're gonna discuss problem C from Codeforces round 648, rotation matching. So you can read the question statement, but in simple terms, it is stated that you are given two permutations of numbers from 1 till n. Okay, as you can see, you are given two permutations of number from 1 to n. And what you can do here is you can cyclically shift this whole one of the permutation. You can cyclically shift all the elements by k times. So as you can see, you can, like, if you cyclically shift this to one left, or to, like, this will shift to this position, this will shift to this position, this will shift to this position, because you are shifting everything to one left. Or else if you are shifting everything to one right, this will come to this position, this will come to this position, this will come to this position. So what you have to do is you will have to cyclically shift this uh, like numbers any k times, such that you want to maximize the matching between the newly formed this array and this array. So as you can see in this, and you have to find the maximum number of matching. So as you can see in this, if you like right shift this matrix, or this vector one time, then this will come to the start, this will go this here, and everything will be right shifted to one position, as you can see in the example, and both of them will become equivalent, and thus this the matching of both the new vector and the original permutation becomes equal, and thus the total number of matching will be 5. But in this, as you can see, you can, like, permute, and in every case there will be only one matching. In this, if you do the permutation, you can find out that there can be two, maximum of two. So I have taken out the first example. So what you can do here is you can find out, you cannot do it for every position, but what you can do here is, let's assume if this 2 will be matched at this position, if it comes to this position, if it's like cyclically shift to one place in the right, it will come to its original place. So now if this cyclically shift to one place, it will come to its original place, or that they will be matched. In this if it cyclically shift to the right by one place, it will come to its place, or you can say it's like right shifted by one place, or you can left shift it by 1 2 3 place. I hope you understand, because so you should make only one thing, because there is no restriction on left shift or right shift. You can only should consider it on the left shift. Now you only consider it on the left shift. So if you left shift this by 3 places, it will become 1 2 3, and everything will become like, you can compute it. You can right shift it by one place, or you can do left shift by 3 places, so it's equivalent. Okay, so this is one observation. Now the next observation can be, if for every number we can find what will be its optimal place. If we right shift, if we left shift, or like if we right shift this whole to one position, then what will happen? Then this will align, and there will be one match. Okay, so for every position, if we find out what will be its likely matching position, then we will count out how many numbers want that they should be at that position. So what my thing is, we want to count out how many numbers will be matched if we like do a right shift by one position, or two position, or three position. How we can find out? So my technique was, I first put the index on every number on A and B. Now what we can do here is, we can so what we can do here is, because if it's not, because it is like sorted in this case, if it is not sorted, actually if it's like this, it's is 1 3 2 4. If it's like 1 3 2 4, and it is at the index 1 2 3 4, and if we sort this, because this is the original value, if we sort by this, it will become 1, 2, 3, 4, which is the original number. So we can like get to these numbers in O of 1 after sorting, and we will know what will be its index in the original value because we have stored the index at this point. So the index will be 1, for 2 it's 3, for 3 it's 2, 4 it's 4. So if we sort this part, we can easily check, like if we want to find out where is 2 in the above matrix, no, above array, because we are searching for 2. If we have seen that 2 is here in this position, but where is 2 in the above vector? So we will directly go to this position and it will tell us that it is on the third position in the original. As you can see, it is on the third position. Oh, so because as you can see, so this is something different. But you can easily find out what is its new position and what is its original position in the above vector by using this technique which I have told you. So you can store the index and the value, sort by its value, and the index will already be sorted, and thus you can directly go to this position and find out what is the index at which it originally at. Now we can easily know the value for 2 here and for 2 here. Okay, so now what we can see here is, if this is at index 1 and this is at index 2, to bring this to this position, how many shifts we have to do? We have to shift it by 1 place to the right. For this also, we can easily find out that its index is 2 and the index in the A vector it's 3. So because this is 3, this is 2, we can easily find out that its index is, we can only have to shift right place 1. So what we can do here is we can make a vector, a map, so which will keep the count, because we have seen we have to shift right place 1 and one element has do this, that we have, that according to one element, as you can see that we are doing a voting. How many shift do you want? He said that I want to shift of only one position such that I can go to my matching. So we have make this one. Now according to this element also we have to shift by one place. So increment is counted 2. This is 3 and 4. So it will become 4. Now for this position, we find out that he wants to go here. Now index of this is 5 and index of this is 1. So if we do 1 minus 5, it's turned out to be 4, which is negative 4, which is not an index. But if we add the total number of elements in the array, which is 5, you can easily go to 1, which will tell us that the difference between this and this is 1. Why we are doing actually this? Because we are not want to go out of bound. If you go out of bound, because the index of this is 1, this is 5, if you subtract 1 from 5, it turns out to be minus 4, which is not in the, minus 4 is not an index. So what we can do is, because we are cyclically shifting, we can add the total number of elements in the vector, which is equal to 5, and it turns out to be 1, which is, we have to shift it by one position, and thus we will make it 5. Now everyone wants it to shift it by one place, and thus we can make a new vector by right shifting it by one place and like only matching it, how many characters are matching, and that's the whole logic. Let's move on to the coding part now. So this is a solve function in which we have taken down the n, a and b, and this is a vector for pairs. I'll tell you, because you have to sort this, a1. So we will take the input for a from 0 till n, we are inputting at from index 1, and then we will also input this vector value in v, which is the first value denotes the value in a and the second value denotes the index, and we will store the b value in this another vector. Then we will sort v, which denotes the value in a, and make an unordered map. We will make our maximum value equal to -1 and cycles equal to, we don't define it, but what we will do is we will iterate over all the elements of b. Then what we will do is we will find what is the position of this bth element in the a vector. So we can put this bi in V, which stores the sorted form, and the second value of this will tell us the index. And the first, so this is the X value and this is the Y value, which is the, so we will get the index of this and we will get the index of this. Now if X minus X is greater than or equal to Y, we can just increment the map value of this value, how many shifts we want. If this number of shifts is greater than maximum, we will update our maximum, else we will not update, or if it goes out of bound, we will not update our maximum. That's the case. Now what we can do here is, because now we know the number of cycles and the maximum number of elements which we want, how many cycles are there, we can just output maximum also, because maximum tells us how many elements want this number of cycles. So the answer is just maximum. I have done this, but the answer is just maximum, because maximum stores how many elements want this cyclic shift. So maximum is just the answer. Or you can also do here is, you can make the answer vector, which is a new vector. You can cyclically shift every element in B to its new position, and then do the matching of how many elements in the A answer, which is the cyclically shift B new vector, and the A vector, how many them are matched, and thus you can print the match. Or you can just not do this, and you can also output maximum, maxi, which is also fine. I hope you understand the logic as well as the code. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Bye.